good afternoon, everybody. Can't believe we're already done with chapter 2 here. Time is flying while we are having fun. So, we have a bunch of problems that I'll take you through. I've done some pre setup work, so during the problem, you might have to do some pausing. But my guess is you're already done the problems and you're just kind of checking your answers. So, in number 1 here, it says Mr. Bartz wants to analyze the age of all the U.S. presidents when they started office. Below is a list of the ages of all 45 presidents on their first day in office. So this is actually legit data, just to let you know. Like, for instance, this data point represents George Washington, John Adams, Thomas Jefferson, James Madison, and Mr. Bartz knows some of his presidents. This was Teddy Roosevelt right here. He was the youngest president. John F. Kennedy was the youngest president ever elected, because Teddy Roosevelt wasn't elected. He actually became in office because McKinley, unfortunately, was assassinated. And then here was Barack Obama. Here's our current president, Donald Trump, right there. He was 70 when he was sworn in back in 2016. All right, so we are asked to do a whole bunch of summary statistics. So just to kind of take you through some of those steps again. So I go to Stat and I go to Edit. This is what I mean how I've already done some of the setup work. I've already typed in all the data points into list 1. I actually have the second problem and the third problem in their respective lists there, so don't worry about all that data if it doesn't match up with yours. So now I'm going to go Stat, Calculate, one variable statistics. I want to make sure it says list 1 right now because I'm doing the president data. I'm going to hit Enter, and it's going to give me all these values, right? So right there, for the mean, okay, the mean was 55. So the average age of all the presidents was 55. The median. So let's get that 5-number summary, in fact. Okay. So in fact, down here it says give the 5-number summary. So I'm going to write the 5 numbers. So when I write the 5 numbers, you'll actually see a lot of times I just write them in a row with commas in between and 70. So I know this is the min, Q1, the median, Q3, and the max. So in fact, the median happens to be 55. The mode, that's going to be the most challenging one. That's going to be the most repeated one. If I look here, I'm just kind of curious. I have 1, 2, 3, 4 57s seem to repeat a lot. But look at these 55s too. So let me see. I have 1, 2, 3 55 so far, 4 55s. Hopefully I didn't miss any. So it looks like 55 and 57 are actually in a tie. So 55 and 57. All right. I don't think there was any other age that seemed to repeat a lot. If I see 261s, I'm kind of curious. If I see 361s, I see 1, 2, 3. Oh my goodness, look at this. I'm glad I'm going 51, 51, 51, 51, 51. There were 5 51s. Cross it out. Oh my goodness. Yeah, 51 is actually the mode. How about that? There's 5 of those. I'm glad I double checked and kind of looked at some other numbers. It just seemed like 55 or 57 was going to be it. So we're just kind of perusing. I think I'm going to be good with 51. All right, so range, max. Remember, it's the max minus the min. Max minus min. So I get 28. So the distance from the lowest to the highest age, or youngest to the oldest, is 28 years. All right, so now let's do a box plot. So since it goes from 42 to 70, I'm thinking I'm going to start here at 40, count by 5s, up to 70. 60, 65, and 70. All right, so I like to start with the middle, 51 to 59. Got a box. My median is 55. It's actually right in the middle. Go down to 42. Go up to 70. So now I want to describe the skewness. Is it symmetric or skewed? So 55 to 70 is 15 to 13. Those are still pretty close. I mean, if I look at that, that does look, it doesn't seem like the left side or the right side super longer. So I'm going to say symmetric. I'm just going to say roughly because I know it's not perfect. Roughly symmetric. All right. And that's it for number 1. Wow, that was pretty quick and easy. That was kind of like the problems in 2.1. Just like these fun problems. I know you're going to have a couple like this on the test, so this is really good review. So on this one, it says, invent a data set that fits the criteria. 7 values, the mean is 10, the median is 15, and the mode is 20. Wow. Okay, so the middle is 15. The most is 20. And when I talk about the mean, 7 values times 10, they have to add to 70. So it has to total 70. So if I have 7 data points, 1, 2, 3, 4, 5, 6, 7, this has to be 15 in the middle because I have 3 below, 3 above. When it's an odd number, it's always in the middle. When it's an even number of data points, you're going to have to do 2 data points to do the average. So this one gets a little tricky because the mode is 20. So one of the things I sometimes will do is I'll go 20, 20, 20. Well, if I look right now, I add these up, that adds up to 75. Oh boy, I'm over 70. Doesn't mean I can't have negative numbers. So I could actually go like this, 0, 0, negative 5. Now I can actually put 2 zeros since I have 3 20s. The key is do all of these numbers add up to 70, in which they do. So that one's kind of a tricky one. Don't forget, you can have negative numbers. There's no rule saying that you can't. All right, next one. It has 8 values, mean is 30. So 8 times 30, so as I think about this, 8 times 30, 8 times 3 is 24, and then I put a 0 after it, so 240. So 8 values, 1, 2, 3, 4, 5, 6, 7, 8. So the median has to be 25. 1, 2, 3, 4. So like right here, notice how I have 4 on this side, 4 on this side. These two have to average to 25. So what's at least I can kind of get away with, so I could make that 25, and I could potentially make this 25. Okay? But since the mode is 35, I got to have 3 35s. Now this might be dangerous here, me putting these in. Let's see how much I have right now. So 25 plus 25 I know is 50. Plus 35 plus 35 plus 35, I think gets me up to 155. So if I go 240 minus 155, this is kind of I'm at 85. Now here's my problem. These 3 numbers have to be less than 25, so there's no way of doing that. So, that kind of stinks. Because now what I kind of have to do is kind of start over here a little bit. Okay? So 1, 2, 3, 4, 5, let's see, 1, 2, 3, 4, 5, 6, 7, 8. So I can't make these 25 and 25. So I might have to go 1 less and 1 more. I actually have to make some bigger numbers. So I already have 50. I need 2 35s. I got to have at least 2 35s. So that's 70 and 50 make 120. Okay, so to make my life easier, I might put this as 100. So I'm at 220. That leaves me 20 for these values. So I just got to make them all different, but add up to 20. So I can maybe go 10, 6, and 4. I think I got it. So that adds up to 20, 70. 70 plus 70 is 140 plus 100, and I got it. Now, when I grade these, I check basically 3 things. Do they add up to 240? Is this here, right here, the median, 25? And is the most repeated, 35? So a question like that might be worth, 3 points on a test. In fact, I know there's a couple of them like that. So, all right, we got 9 values. 3, 4, 5, 6, 7, 8, 9. Okay, so the median is 7. I like it when it's odd because I go 1, 2, 3, 4. The 5th data point must be 7 since I have 4 below, 4 above. Okay, the mean is 8. So I know that 9 times 8, 72. All of these have to add up to 72. and the mode is 6. Okay, so need to be kind of careful here. So I do need some 6s. So I might go 6, 6, and 6. Leave that one blank. So I'm going to start to see what I have right now. So 3 6s make 18. 3 times 6 is 18 plus 7 is 72. I'm sorry, it's not 72. It's 25. If I'm thinking ahead, 72 minus 25 means I still need 47. So I'm trying to think, boy, if I can get these to add up to almost all the 47s. So like if I go like 8, 9, 10, okay. So if I add those two, that's 27. That still leaves me 20. So I could go like 20 here and 0 here. And I think I got it. So I can just do a quick check. That was 25 again. 35, 45, 55. 65 minus 1 is 64. Plus 8 is 72. Sweet. I got all my answers on that one. All right, so that takes care of the first page of the review. All right, second page. It's just more similar to number 1. It says, Mr. Bartz wants to analyze test scores on a recent exam taken by students in his regular stats class. The scores on the test are listed below. So as you can see, the scores range from anywhere from 22 to 50. So here's the nice thing. Mr. Bartz, if I go back to my stat, if I were to enter them in, he's already got them in. You can see he's got them already here listed in list 2. So he's going to go stat, right arrow to calculate number 1, but he's got to make sure it says list 2. Otherwise, he'll start writing down all the present data. All right, so all of a sudden, I can now start writing all my answers. My mean, 41.3448, so we'll just say 3, 4, we'll go 2 decimal places. The median, let's scroll down to our 5-number summary. Median was 42. In fact, I'll write my 5-number summary since it's there. 22, 39, 42, 45.5, and 50. My mode, which score was repeated most? This one's at least a little bit easier to find the mode because they're in order. So I have 2 240s, 3 41s, 3 42s, 2 43s, 2 44s, 3 45s, a couple 46. So I actually have 3 numbers, 41, 42, and 45. That one was a little bit easier since it was in order. Range again, max minus min, 50 minus 22, range of 28. So the test scores have a distance from lowest to highest of a total of 28 points. All right, draw out the box and whisker plot. This is where the 5-number summary. Remember, here's my min, Q1, median, Q3, and max. So 22, so I'm going to start at 20, go up to 50, so 25, 30, 35, 40, 45, 50. All right, so 39 to 45 and a half. So 39 to 45 and a half, just a little bit past 45. 42. Then I go all the way down to 22 and then to 50. So this one's easy to see that this one is skewed, and the direction it's going to is to the left because it's going to the left side. All right, find the standard deviation. That's calculator. So that's S of X. So my standard deviation is 6.1194, so 6.119. So that's the S of X right here on my calculator. Interquartile range, remember, that's Q3 minus Q1. This is going to be very helpful when we do the outlier part. So 45.5 minus 39, which is 6.5. All right, so now it says to use the rule to name any outlier. So remember, outliers, by definition, are values that are greater than the third quartile plus 1.5 times the IQR, or less than Q1 minus 1.5 times the IQR. So here's the cool thing. Here's my IQR. So over here, I'm just going to go 1.5 times the IQR. So 1.5 times 6.5 equals 1.5 times 6.5. Whoa, it didn't take my decimal. 1.5 times 6.5. 9.75. So what's going to happen is I'm looking for values that are greater than Q1, so 45 point, whoops, forgot the point, 0.5 plus 9.75. So I'm looking at values that are greater than 55.25 or less than Q1, which is 39 minus 9.75. Values that are less than 29.25. So now I have to go up and look at the data. Well, no one scored better than 50, so I don't have any values greater than that 55.25, I think it was, or 75, I'm trying to remember, 25. Less than 29.25. Look at this. You actually have two values, two test scores. So in this case, our outliers are at 22 and 28. Sweet. All right. That takes care of the second page. And question number 3. Last page here, question number 4. Mr. Bartz wanted to know how much time students typically spend on their cell phone on a given day. Below is the number of minutes 30 randomly selected students spent on their phones on a typical day. Wow, only 10 minutes. That's actually pretty impressive. All the way up to 360. That's like 6 hours a day. Crazy. All right, so now in A here it says, construct a histogram for this data using a bin width of 50 minutes. This is important. So if you see these directions on the test, you gotta follow it this way. That way we all get the same histogram. Okay, so here's going to be my frequency. Okay, and then I'm going to draw this out, and I'm going to do bin widths of 50. So I go 0 to 50 to 100, 150, 200, 250, okay, 300, 350, and I actually have to go all the way out to 400. So this first bin width, okay, is from 0 to 50, but not including 50. So I'm going to kind of start to group them. So I have this group. Then I have between 50, but not 100. There's that group. Between 100 and not 100, all the way up to, but not including 150. 150, all the way going up to 200, but not including 200. 200 to less than 250, 250 to less than 300, 300 to 350, oh, nothing here, and then the last one. It's going to be important. You're going to see a little space in it. So the reason why I like to do that is it kind of gives me a sense of, I think my highest bin width looks like it's going to be like 5 or 6. So for my frequency, I can, make these 1, 2, 3, 4, 5, 6, 7, 8. I'll go all the way, but 2, 4, 6, 8. So from 0 to 50, I had 4 data points. Was this first grouping. Next group, 62 or 50 to 100, but less than 100, was also 4. Then the next group, 1, 2, 3, 4, 5, 6. So that goes up to 6. Then next group, 1, 2, 3, 4, 5, 6. Wow. That was 6. Next group, 1, 2, 3, 4, 5, 6. Oh my goodness. Scary. Then 1, 2, 3. Now notice on this one I had 0. And then last but certainly not least, I have a 1. So there's actually a gap in our histogram here. Kind of cool to see. All right, so now B says find the interquartile range. So, thank goodness Mr. Bart's stat edit has them in list 3, because interquartile range, remember, is Q3 minus Q1. So I'm going to use my calculator to say stat, calculate, one variable statistics, and he's entered them into list 3. I'm going to calculate it out. And so now to help me find it, remember, Q1, 210, Q3 was 210, Q1 was 90. Subtract those two and I get 120. So now it says use the 1.5 times IQR definition to name any outliers. Make sure you show all of your work. Okay? So I want to go 1.5 times IQR first. So 1.5 times 120. What does that equal? Well, 1.5 times 120 is, whoa, I forgot the decimal. So just to note, if I times it by 0.1 because of the decimal, it gives me 180. So I'm just kind of doing a time save because I just forgot the decimal in there, the 10th. Okay? So this is what I have to add. So I go Q3 plus 1.5 times IQR. So 210 plus 180 is 390. So if it's greater than 390, it's an outlier. Q1 minus 1.5 IQR. So 90 minus 180 is negative 90. So any value less than negative 90. So outliers are defined by these values. Well, the longest anybody talked on their phone was 360 minutes, and you can't have negative minutes on the phone, so we have no outliers, even though 360 minutes seems like a lot of minutes. All right, the last problems here. We're doing percentile. Good review. Izzy was on her phone for 195 minutes. What percentile would she be in? Ooh. So this is where we go back to the data set. So when we talk about Izzy is this data point right here, 195. Just to let you know, there were 30 randomly selected students. Okay? So how many students talked less than Izzy on her phone? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, this is a row of 10. So this would be a row of 9. So there are 19 students that talk less than her out of, whoops, sorry, I think my shadow blocked that for a second, 30. So if I go 19 divided by 30, this gives me her percentile. She's in the 63.3 percentile. All right, Jose was on his phone for 290 minutes. What percentile would he be in? Whoa, he's right here. So there are him and one above, so 2 students that are not below him. So another way of thinking about that is there would then be 30 minus 2 is 28 divided by 30. Oops, I forgot the equals there. So 28 divided by 30 is 93. So he's in the 93rd or 93.3 percentile. All right, that wraps up your review. Should give you a nice, great preparation for your test tomorrow. All right, let me know if you have any questions before we do the test. That way I can help answer, clear anything up. And we will talk to you a little bit tomorrow. All right, see ya. Have a great day.